you don't have anything to write down, this is printed up because it's much easier to go ahead and print it up. These are the rules we're going to be using today and the terms we have. We have the index is the power of our root. What root are we taking it to? Okay, cube root, fourth root, fifth root. The only index we don't write, normally when we don't write a number, it's either 0 because we don't add or when we're add or subtract 0, we don't write that, or 1 if we're multiplying or raising to a power of 1. Radicals are different. We don't write the index. That's an index of 2. Square roots, we don't write the 2. But square roots have an index of 2. We just don't write it. Any other index, we do that. And it's how many times, whatever that index is what times itself that many times gives us that number. So 8, the cube root of 8 is what number times itself 3 times gives us 8. That's what the indexes are. Okay, kind of opposite of powers. Okay. A couple of formulas you need to understand, and we're going to have powers and stuff coming up. If I am multiplying 2 radicals where the index is the same, the index must be the same. I can combine them together into 1 radical of that same index. The more important thing is, for our purposes here, is we can also split them. These rules, these formulas go both directions. A lot of students don't think about that, but they go both directions. Almost everything you do in math goes both ways. The rule applies in both directions. The distributing property is a big one. Whenever you pull out a common factor, you're using the distributive property, pulling out the thing rather than just multiplying it through, but pulling it out as factoring is using the distributive property. Most students don't think about it that way. Oh, when I distribute, I'm just taking whatever's inside times whatever's out front. Well, if I take something and put it out front, I'm doing distributing. I'm just doing it in the other direction. It's the same property. So we're going to do a lot of going from here to here. That's how you simplify radicals. Okay, and we're going to be simplifying radicals, and that's what you do. You take 1 radical, split it up into 2 or 3 or 4 radicals. That's what you do. So this rule is actually going to be used in this direction more often. Same thing goes with dividing. The only thing is our denominator cannot be, what are we not allowed to have in a denominator at any time? 0, because if you divide by 0, the world ends. Well, not exactly, but it just doesn't work. Okay? Questions on this? Okay, let's get to it then. So, simplifying each radical. So, what is the cube root of -8? Well, you should know your powers, and we talked about this before. You should know powers of certain numbers. 1 cubed, 2 cubed, 3 cubed, and the roots go in the opposite direction. So we talked about this last semester. You should know all your perfect squares. Okay? You should know all your perfect cubes up to like 5 cubed or 6 cubed. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, takes a minute sometimes, 5 cubed is 125, and 6 cubed, just for snorts and giggles, is 216. I seriously doubt you're going to have to deal with 216. Usually it's these first ones here you have to know. The roots go in the opposite direction. What times itself 3 times gives me 8? 2. Now, we used I before, right? I was the square root of -1. If we have an index other than 2, I does not apply. And I'm not going to give you any negative underneath the radicals unless you can do it. Here's a rule. If it's an odd root, your answer, you can have a negative root. The cube root of -8 is -2. -2 times -2 is +4 times -2 gives me -8. If you have an odd root, cube root, 5th root, 7th root, 9th root, and you can take an odd root of a negative number and it's okay. There's no issues with that. Okay, there's no issues with that. Okay. You do have access to calculators, but these should all be doable without a calculator. Okay. Square root of 0.04. Okay. 4 is a perfect square, right? So what's the square root of 4? 2. How many numbers do I have after the decimal point? 2. When I take the square root, my answer is going to be the number of numbers after the decimal point is going to be half of that. Always. If I have 4 numbers, if I had 0.0004, it would be 0.02 would be my answer. Half the number of decimal points. 2 decimal points, that means I'm going to have 0.2. Yes? No, please, if you start as a decimal, keep it as a decimal. Does that make sense? If you start as a fraction, general rules, standard operating procedure, decimals, stay decimals. Whole numbers and fractions are whole numbers and fractions. The only time you veer from that is if you're doing word problems or something really complicated and decimals are okay. And this isn't that complicated. Cube root of 127. This is one where splitting it, taking 1 and splitting it into 2 makes it very helpful. Cube root of 1 over the cube root of 27. What's the cube root of 1? 3. What times itself 3 times gives me 1? 1. 1, the root of 1, and 1 to any power is 1. Okay, what's the cube root of 27? 3. So that's 1/3. Now, a lot of students freak out with fractions. Okay. 4th root of 81. Now, I know what this is, but I've been doing this a long time. Please, get out your calculator if you have your calculator handy. If you do not have a calculator handy, grab one of mine. Ooh, it's getting windy out here. Because you're going to want to know how to use tools. Okay? You're going to need to know how to do radicals on your calculator. And it's not always easy. It depends upon how your calculators look and what they have, the keys that they have. Here's what you are looking for. You were looking for somewhere on your calculator something that looks like this. It might look like that. It's usually not a key, but usually above the key. Does that make sense? Usually the key that is above is usually a square root key if you have a square root key. So usually that's where you will usually find them on your calculators. You need to know how to use them. So like on these, it's actually above the caret key. So on these ones, the ones that I have, it's actually above. It's called the caret key. The little up arrow, that's called a caret. Okay, not like Bugs Bunny eats, but a caret. That's what that's called. It's called a caret. Okay. A caret lets you raise things to a power. So if I want to type in, let's say 3 to the 5th, if I want to do 3 to the 5th, I would type in 3, hit the caret key, and then 5, and then enter. And that would give me 3 to the 5th power. Okay. Roots are the same way. In order to do, let's do the one we're doing there, the 4th root of 81. This is the key you're going to need. But to do this, you need to do shift. So let me make sure I'm getting this correct because it's been a while. Let's turn it on. I have to turn it on first. So if I understand, you type in the base, 2nd key. Nope, backwards. Okay, so if you have one of my calculators and yours will be similar, we need to make sure that everybody knows how to do this. I want to do the 4th root of 81. Here's what you do. You type in 4. And then on mine, you hit 2nd. Little key that says 2nd. And that lets you do X root. And then you hit that one, which is above the caret key on here. And then you type in 81. And then you hit enter. And you should get 3. 4th root of 81 is 3. Oh, that's a good question. Good question you brought up. So you get 3. The question should it be plus or minus 3? Well, I'm going to tell you, I'm not going to worry about the plus or minuses on these so much. When we get to solving and stuff, pluses and minuses will be more important. On here, we'll do that. And that only applies to even roots. Even roots can be plus or minus. Odd roots are either plus or minus, not possibly both. But we're not going to deal with that. We're just going to go ahead and go with the positive roots. Just go ahead and leave it at plus 3 and we'll be good. Good question, though. Okay, good question, though. So did everybody figure out how to do this on their calculator? Okay, if you didn't, you're not sure, and you want to ask again, I'll be glad to help you learn how to use your tools properly, because that is an important thing. You're going to want to have them for your test. You're going to want to know how to use them, properly. Okay, when you're using a hammer, you don't bang the handle, you bang the head, right? Okay, when you have a nail, you hit the flat part, not the pointy part. You need to know how to use things properly or they don't work. Calculators the same way. You've got to know how to use your tools properly. Now, well, make sure you understand you know how to use them for this stuff in here. Okay. Now, we dealt with this one, square root of 40, negative 49. Square root of 49 is what? 7. And because I have a negative inside the square root, and only with the square root I have 7i. Fifth root of negative 32. Okay, go ahead and try to do this on your calculator. See what you come up with. See if you can do this. I know what it is. And there are some numbers you should be able to get anyways after a while. And if you're into computers, you better know what the fifth root of 32 is. So if you're into computers and programming, you better know your powers too. So what we get? Negative 2. Ooh, now we got variables involved. Uh-oh. That's not that big a deal. Break it up into parts. Square root of 25 times the square root of n to the 4th. Well, the square root of 25 we know how to deal with, right? What's the square root of 25? 5. Square root of n to the 4th. This is where it gets a little hairy. Okay? Take your index. What's my index on the square root? It's 2. My index is 2. Take the exponent of your variable. What is the exponent of my variable? 4. Take 4 divided by 2. What do I get? 2. If it's evenly divisible, 4 is evenly divisible by 2. That's my new power. For square root, it's half the power. Half of 4 is 2. So that's n squared. Okay. Not so bad. Next one's a little more complicated. They're not even. If it's the square root of an even power, it's just half the power. If it's the square root of an odd power, things get a little funny. Because it's like taking the square root of 12. Square root of 12 is 2 root 3. You have some we can pull out and some we have to leave behind. Same thing here. Some of it's going to come out, some of it's going to stay behind. Here's what you do. What's my index? My index is 2. 3 divided by 2 is what? What is 3 divided by 2? Come on. 3 divided by 2 is 1 with a remainder of 1. 2 goes into 3 once with the remainder of 1, right? How many times it goes in is my power for the outside. Whatever my remainder is my power left over for the inside. So c, the square root of c cubed, I pull c to the first power out, and I have c to the first power still left behind. Okay. Do the same thing with d to the 9th power. 9 divided by 2 is what? Remainder what? 4 remainder 1. So that means I have d to the 4th out front and d to the 1st still inside. D to the 4th, d to the 1st inside. extend the page and move it up to make it easier to see. Okay. These are going to be a little bit different because they're different index. Do the same thing. What is 12 divided by 3? 4. What's my remainder? 0. I don't have a remainder, do I? Ooh, that's great. That means I pull out all my A's. I don't have anything left behind because my remainder is 0. So the cube root of a to the 12th is a to the 4th. And then I do that to b to the 15th. 15 divided by 3 is 5 with the remainder of 0, so there's nothing left inside. It goes in evenly. If it goes in evenly, just take the power, divide it by the root. That's b to the 5th. That's an easy one. Ooh, 4th root of x to the 16th, y to the 5th. Okay, 4th root of x to the 16th. 4 goes into 16 4 times evenly. So just dealing with this part here gives me x to the 4th. Now I have to take the 4th root of y to the 5th. 4 goes into 5 how many times? Once with the remainder of 1. So that means I have y to the 1st outside and a y to the 1st left still inside the radical. And my radical is the 4th root. Do not lose your roots. Do not lose that index. Those indexes have a habit of disappearing. And if you were to give me and drop that 4th root on the index, I would drop your points on a quiz. Okay? They have a habit of disappearing along the way. It's one of the most common errors when I'm grading simplifying radical quizzes.
So because they're only 3, cancel everything else out?
Yeah. Yeah. So let's get to the next one here. 5th root of 32m to the 7th. Okay, we already did the 5th root of 32, right? 5th root of negative 32 is 2, so the 5th root of positive 32 would be positive 2. So just this part right here, 5th root of that, gives me 2 all by itself. I don't have anything left behind. M to the 7th. Okay, 5 goes into 7 how many times? 1 with the remainder of 2. So that means I have m to the 1st outside, and my 5th root still stays there. And m to what power on the inside? 2nd power. Okay, m to the 2nd power on the inside. If you're doing square roots, you will not have a power of anything larger than 1 left inside. If you're doing a root other than a square root, you might have a power higher on the inside. But your power inside will never be larger when you're done simplifying than your index. Never. Okay? Your turn. All right, so the 4th root of 81 we established earlier is 3. Cube root of negative 27 is negative 3. Cube root of m to the 6, 6 divided by 3 is 2, so it's a perfect m squared. We're going to make that better, m squared. Next one's a little goofy. The 4th root of x cubed, 3 is not evenly divisible by 4. It doesn't go in, so I can't simplify that. The power is already smaller than my index, so the 4th root of x cubed stays the 4th root of x cubed. So that just stays. There's just no change on that. Now I can do the 4th root of y to the 8th. 8 divided by 4 is 2, so that means I have a y squared out front. Okay, some is inside, some stays outside. That's just the way it is. This is square roots. This is nice. Everything's a perfect square because these powers are even. So I can divide them evenly by 2. Square root of 49 is 7. Half of 12 is 6, so I get a to the 6th. Half of 14 is 7, so I get b to the 7th. Okay. Cube root of 81. It's not a perfect cube, is it? No, it's not. But it's close. So we did simplifying square roots. It works the same thing with cube roots. Cube root of 81 is the cube root of 27 times the cube root of 3. Just like we do the cube square roots and simplifying the squares, perfect square and a perfect and whatever's left over, cube roots you do a perfect cube and whatever's left over. 27 times 3 is 81. What's the cube root of 27? 3. That means I have a 3 and a cube root of 3. That's what the cube root of 81 is. It simplifies out as a radical, just like square root simplified. Only instead of looking for perfect squares, I'm looking for perfect cubes. Okay. N to the 6, that's easy. 6 divided by 3 is 2, so that's n squared. Okay. And then p to the 8th, 8 divided by 3 is 2 with the remainder of 2. So that means I have a p squared outside and a p squared still inside. Come on. There we go. Move this up so we can see. 8th root. Okay. 9 divided by 8 is a 1, remainder 1. So with the a, I have a to the first outside and the 8th root of a to the first on the inside. B to the 16th. 16 divided by 8 is 2 with no remainder. I have a b squared outside that comes out. C to the 13th. 8 goes into 13 once with the remainder of 5. Thank you. C to the first outside, C to the 5th left inside. Okay. And the next one, oh man, that's an easy one. Can't get much easier than that. The power on the outside is the 10th digit, and the power left on the inside is the 1's digit. Because 10, any one of these numbers divided by 10 is the 1's digit with the remainder of the 10's digit. 10 goes into 12 once with the remainder of 2. Do you see what I'm saying? So this one's a really easy one. I have x to the first, y to the first, z squared, and then I have the 10th root of x squared, y to the 5th, z to the 9th. And that's just understanding arithmetic makes that a little easier. Yes, sir.
You can go back to the fourth one.
Okay. So it's y to the 8th. I can pull out y squared because 8 divided by 4 is 2. And then I can't do anything with the x cubed, so I have the 4th root of x cubed is still there. Yeah, it's a little shoved together. That's my bad.
All right.
Okay? Questions? Yes?
Can you explain the one with the one at the bottom? No,
This one?
no, the one on
This one? Okay, so did it in parts. Do you understand the end of the 6 and p to the 8th? Because we've done that. Because I'm guessing here that the problem is with the cube root of 81. Okay, let's step back and let's take an aside and look at square roots. Remember we did the square root of 12 and you simplified the square root of 12. We did simplifying radicals. What you do, you said, oh, that's the square root of 4 times the square root of 3. 4 times 3 is 12. And what were we looking for? We were looking for a perfect square, right? Okay. That's what we're doing here. 81 is 27 times 3. Why not 9? Because 9 is a perfect square, not a perfect cube. If we look over here, these are my perfect cubes. Oh, 27. 27 times 3 gives me 81. So I have a perfect cube times a perfect cube. If I go back to my squares, square root of 4 is 2. So this gives me 2 root 3. If I go back to this one, it says, oh, the cube root of 27, that's 3 cube root 3. So this cube root of 81 is that. Now, don't get in too much of a panic. You're not going to see an awful lot of those. You may see them from time to time. Don't get too much. You will see this more often than you will some other powers. But it works the same way, same basic concept. Only instead of looking for a perfect square, you're looking for a perfect cube. Okay, and I'm not going to do it to you on a 4th root or something like that. I'm not going to do that. I might be mean from time to time. I'm not that mean. Okay. Okay. Multiply and simplify each radical expression. Now, you have choices when you're doing this. You can simplify and then multiply, or multiply and then simplify. Kind of depends on the numbers I'm dealing with. Okay, kind of depends upon what I'm dealing with here. When I have the first one, 4th root of 8 and 4th root of 2, I can't really simplify anything anyways. But I can go ahead and multiply them. Now I can multiply them because the indexes are the same. They're both 4th roots. So the fourth root of 8 times the fourth root of 2 is the fourth root of 2 times 8, or the fourth root of 16. So this is the fourth root of 16. And what is the fourth root of 16? 2. So this is 2. That's my final answer. The indexes are the same. I can multiply. The indexes are different. I can't do this. Cube root times the fourth root. Sorry, it's still cube root times fourth root. Nothing I can do about that. They have to have the same indexes, or you can't combine them up. This one I can because they're both square roots. Okay. Now, 45 times 35 is going to get ugly in a hurry. Okay. This is one where I'd rather mess around a little bit with my numbers first before I multiply. Does that make sense? So, off to the side, I'm going to work off to the side over here. Square root of 49 and is 45 and see what I can get from that. Okay. Square root of 45 is the square root of 9 times the square root of 5, which is 3 root 5. Does that make sense? Do you see how I did that? Okay. What about the square root of 35? Can I do anything to that? I can't. Can I? There's no perfect square that goes into 35. 35 is 5 and 7. That's the only two numbers that multiply to give me 35. Neither one's a perfect square. But keep in your head that 5 is one of the numbers times 35 in 35, right? Keep that in your head. Keep that in the back of your head. I'm not going to mess with the rest of it. I'm going to leave the rest of it alone. I'm just rewriting the first one. So I have 3 square root of 5x to the 5th y cubed times the square root of 35 x to the 1st y to the 4th. And there's a reason I did this, and you don't have to, but I'll explain my reasoning here in a minute. Now multiply. Everything outside the radical stays outside the radical. Everything inside the radical stays inside the radical. So I still have a 3 out front, and then I have one big radical. 5 times 35. 175. X to the 5th times x to the 1st is x to the 6th power. Add the exponents. X to the 6th. And then y cubed times y to the 4th is y to the 7th power. Okay. Am I done? No. Do you wish I was done? Yes. I'll be honest. I'm a little tired today. I wish I was done too, but we're not. Okay. So, all right, let's take a look at what we got going on here. Square root of 175. Give myself a little room to work here. Square root of 175 is the square root of 25 times 7. If it ends in, if it's a number that ends in 00, 25, 50, or 75, it's divisible by 25, and 25 is a perfect square, right? Okay. What's the square root of 25? 5. So this is 5 root 7. Root 7, not 6. 7, you idiot, not 6. So 5 root 7 is the square root of 75. I already have the 3 out front, right? So what's out front gets multiplied by what's out front. So my numeric values, I get 15 for the 3 times the 5. And then still inside my radical, right now it's a 7. That's just dealing with the 3 times the square root of 175. That's what it comes out to be. No matter how you look at it, these numbers are big, they're ugly, it's not pretty. Sorry.
Where does it come from?
3 times 5. The 3 that's here times the 5 that's there. Okay? You see it? Now I'm dealing with those with the powers. Or sorry, with the variables. Square root of x to the 6th. X cubed, that's easy. 3 is evenly divisible by 2, that's x cubed. Okay, and then y, square root of y to the 7th. 2 goes into 7 3 times with the remainder of 1. So I have y cubed outside and y to the first left inside. I know, it's not pretty. It's not always pretty. Not always the best things are. In fact, some of the prettiest things are not always good. Okay. Next one, more complicated. It's not bad. Still multiply them together first. So what's outside stays outside. 2 times 3 gives me 6. So I have a 6 square root 6 times 18. I believe it's 144. Could somebody with a calculator please check that 6 times 18 is 144?
108.
108?
18 times 6.
18 times 6, 108? Ooh, I was wrong. Don't tell anybody. 108. Okay. Now, then I multiply the rest of them together. A cubed times a to the first gives me a to the 4th. B squared times b to the 7th is b to the 9th power. Now the fun begins. 108. Perfect squares to divide into 108. Well, I can think of 2 right off the top of my head, but I know what the bigger one is. Okay, it's divisible by 9. 9 times 12 is 108, because I know my 9s. Look at the last 2 numbers. If the last 2 numbers of a number are divisible by 4, the entire thing is divisible by 4. So like, if you look at the last number, it's divisible by 2, the whole thing is divisible by 2, no matter how big it is. The last 2 numbers are divisible by 4, the whole thing is divisible by 4, no matter how big it is. Same thing here. 0.8 is divisible by 4, it's divisible by 4, of course, square. I also happen to know that because it's divisible by 9 and divisible by 4, it's divisible by 36, which is a perfect square. Matter of fact, it's 36 times 3. I'm helping you out here as best I can. Hopefully the numbers, I know the numbers on your test are not this big. And I know the numbers on your test are not this big. I'm not that mean. Okay. So 36 times 3, what's the square root of 36? Square root of 108 is equal to the square root of 36 times the square root of 3. Square root of 36 is 6. So this is 6 root 3. So that's 6 root 3. I already have a 6 out front, right? So I get this 6 times this 6 gives me 36. So I have 36 root 3. That's my numeric value. And I think the numbers are so much harder than the variables are. I really do. The numbers are so much harder than the variables are. The variables, you just divide the power by the index and whatever remainder whatever. So like a to the 4th. 4 divided by 2 is 2 with the remainder of 0. So I have a squared outside. Okay. Square root of a to the 4th, that's easy. It's a squared. It's a square. It's a square. B to the 9th. 9 divided by 2 is 4 with the remainder of 1. B to the 4th outside, B to the 1st still inside. Like I said, the numbers are ugly. There's no getting around that. I'm sorry about that. They just are. There's no helping out. The variables, I think, are actually easy hard. Oh, it's your turn. Okay. So let's do it. So first one, 4 times 3 gives me 12. And then inside the radical, 2x times 8x gives me 16x squared. It's an easy one. And so I still have my 12 outside. And then if I simplify 16x squared, I get 4x. 12 times 4 gives me 48x. Okay. Next one. Same thing. 7 times 12 gives me 14. Square root 3 times 6 is 18. And then I don't have any x's in this one, but I do in the second one. X cubed, y cubed. Okay. 18 is what? What's the perfect square goes in 18? 9. It's 9 times 2. So square root of 18, square root of 18, square root of 9, square root of 2, 3 root 2. So I have 3 root 2 times 14. Okay, what's 3 times 14? 30 plus 42. So I get 42, and then I have root 2. So the 3 root 2, 18 is 3 root 2. 2 there. The 3 that I pulled out times 14 gives me 42. Okay. Square root of x cubed is x on the outside, x on the inside, one of each. X and x. Y cubed, same thing. One on the outside, one on the inside. Make sure your radical goes all the way. Be careful of that. Make sure your radical doesn't get shortened out. You leave something hanging out there. You want to make sure that everything that's in the radical is supposed to be there. Notice sometimes I put a little hook on the end. So my radical goes all the way, it ends here. I know exactly where it ends. Something I don't always do, but I do it from time to time. So I know where my radical ends. Next one's a little more difficult. It's a cube root. So I have the cube root of 50 times 15. 5 times 15 is 75. And throw a 0 on there, so I get the cube root of 750. And then c squared, oh, I almost forgot this b. I got a b squared there. Don't want a b squared. So I get c squared times c cubed gives me c to the 5th. And then d to the 5th times d to the 1st is d to the 6th power. Okay, so cube roots. So I have to simplify the cube root of 750. So I start thinking about my perfect cubes. And I go, no, maybe. Does 125 go into 750? Yeah, 6 times, right? 6 times. So that means the cube root of 750 is the cube root of 125 times the cube root of 6. And the cube root of 125 is 5. So I have a 5 and a 6 left inside. Okay, so I have 5 and a cube root of 6 left inside. And that's the hard part. The variables are easy. Cube root of b squared. 2 is smaller than 3. I don't have any b's pulled out. My b squared stays inside. Cube root of b to the 5th. 5 divided by 3 is 1 with the remainder of 2. So I pull out a c and leave a c squared inside. Pull out a c and leave a c squared inside. D to the 6th. 6 divided by 3 is 2 with no remainder. No d inside. I pull a d cubed outside. Questions? So we're flexing our mental muscles. Right? Any questions? Okay. A couple of tricks to some of these. We'll work through them. These are pretty easy for the most part. Once again, the numbers are the most difficult part. The numbers are the most difficult part. I can divide or I can't divide. I can have choices. When I look at the first problem, I'm going to do it different than I'm going to do the other ones. Okay? 25 and 49 are perfect squares. I'm not going to mess with it because I already have a perfect square in my denominator in particular. The denominator is pretty much what drives everything. If my denominator is a perfect square, I'm not screwing with it. Because I don't want to mess with that perfect square. And d to the 4th is a perfect square. My denominator is the square root of a perfect square. I'm not going to try to simplify it. I'm just going to take the square root of my denominator. And I'm going to take the square root of my numerator. I'm not messing with anything because I have the square root of 49 there. That's the big deal on this one. So when I look at this, I do the square root of the numerator over the square root of the denominator. Square root of 25 is 5. Square root of c squared is c. You got to go? All right. Square root of 49 is 7. Square root of d to the 4th is d squared. Easy peasy. No more radicals. Okay. And the reason I did this one this way is my denominator is a perfect square. I'm taking the square root of a perfect square. I'm just not going to mess with it at all. I'll just deal with that. Whatever happens in the numerator happens in the numerator. I don't care. Next one's a little different because I don't have a perfect square there. So what I want to do is I want to simplify it first and then deal with the radical. So, a couple of steps. The rules say that I can take a radical, the square root divided by square root, and write it as 1 square root. The rules say I can do this. 18x to the 5th over 2x cubed. Remember, that was one of the first rules we had. 2 multiplied, combine up, 2 divided, combine up, and vice versa. You can split it too. Now I can just do my division first and then do the radical. Do you see why I did this? 18 divided by 2 is what? 9. So I have the square root of 9. And x to the 5th divided by x cubed is x. What do you do to the powers when you divide? You subtract. 5 minus 3 is 2. So this is x squared. Oh, square root of 9 is 3. Square root of x squared is x. 3x. Piece of cake. And, ooh, my indexes are the same. I can do the same thing in the next one. I don't have a perfect cube in the denominator. I'm going to simplify it and then deal with my cube root. Because I don't have a perfect cube. If I had a perfect cube in the denominator, let's say that was 8b cubed or something like that, I'd take the cube root and deal with the numerator separately. But it's not a perfect, so I'm going to combine them up. Technically, we can go ahead and skip this part and just go ahead and do it, because they're both inside the radicals. So 21 divided by 7 is 3. So I have the cube root of 3. B to the 10th divided by b to the 1st is b to the 9th. 10 minus 1 is 9, b to the 9th. Now I can simplify my cube root. Can I simplify the cube root of 3? No. Cube root of 3 is cube root of 3. Nothing I can do about that. Cube root of b to the 9th, though, I can. What's the cube root of b to the 9th? What's 9 divided by 3? 3. So I have b cubed. So this b to the 9th gets pulled out to become b cubed. And then I have cube root of 3 because I can't do anything with my numerical value. That's that. Notice I did the second two different than I did the first one. And that's because I looked at the problem first. I go, ooh, perfect squares. I'm not screwing with it. If I don't have perfect squares, then I'm going to simplify first and see what happens. Okay? Your turn. And squares and roots go the same way. So like you have a 4th root here and a 4th root there. Think about doing the same thing there with your 4th roots. Perfect 4th roots, that's a hint. Not perfect 4th roots, that's also a hint. Okay. Okay, let's finish this up. Okay, so the first one, I don't have a perfect square on the bottom. So I'm going to go ahead and simplify it out. 63 divided by 7, square root of 9. My a doesn't change. B cubed divided by b to the 1st gives me b squared. So that's 9ab squared. Okay, so 9 is a perfect square. So I can pull out 3. Square root of 9 is 3. B squared is a perfect square. Half of 2 is 1, so that's 3b. A is left behind, so I have 3b square root of a. Okay. Second one, same idea, do the same thing. 54 divided by 2 is 27. Square root of 27. X to the 5th divided by x squared is x cubed. Y cubed divided by y is y squared. Okay. Square root of 27. Square root of 9 times square root of 3, so I get 3 root 3. So I have a 3 outside and a 3 inside. X cubed. Square root of x cubed. 1 root 1 remainder 1. X to the 1st, x to the 1st. And then y squared. Oh, that's a perfect square. Square root of y squared is y. These two here where things get a little more difficult, but they're not too bad. The second one's actually easier than the first one here. So this one's kind of goofy. Let's take a look at this step by step. Numerically, just looking at the numbers. 243 divided by 3. Okay, and actually I'm going to combine this up into one radical and divide and simplify at the same time. So I have the fourth root of 81. 24 divided by 3 is 81. So I have the fourth root of 81. And I'm still going to have a fraction. You'll see why with the C's. So I don't want to deal with negative exponents. So when I divide, normally what I do, I subtract. 3 to minus 11 is negative 8. So it'd be c to the negative 8. I don't like that. When my denominator is bigger, I just subtract and put it on my denominator and make it positive. So I get c to the 8th in my denominator, because 11 is bigger than 3, so I have a positive power in my denominator. We're going to work more with these later, with denominators and powers and stuff later. And then d to the 6th divided by d squared. 6 minus 2 gives me d to the 4th. And now this is easy because those are all perfect fourth powers. Fourth root of 81 is 3. Fourth root of d to the 4th is d. Fourth root of c to the 8th is c squared. So they all disappear altogether. Now the next one, goofy. My denominator is a perfect fourth root. 81, the fourth root of 81 is 3. The fourth root of d to the 16th is d to the 4th. So I'm not going to simplify first. Okay? So I'm going to go ahead and deal with my denominator first all by itself. Fourth root of 81 is 3. Fourth root of d to the 16th is d to the 4th. 16 divided by 4 is 4. And now I have the fourth root of 16 n to the 8th in my numerator. Well, the fourth root of 16 is 2. I don't have it up here, but the fourth root of 4 times 2. Fourth root of 16 is 2. Now I have to do the fourth root of n to the 11th. N to the 11th is not a perfect fourth root. But because it's in my numerator, I don't care. I can deal with the extras left over. 11 divided by 4 is 2, remainder 3. So I pull out an n squared. And I'm left with the fourth root of n cubed still in my denominator. That's my answer. My denominator is a perfect root. Man, I do not mess with it. I just make it my perfect root. Take care of it. Deal with the numerator however I deal with the numerator. Okay? If it's not, then I'll simplify and deal with it. Okay? Questions? I do believe that's it, right? Yep. Good.